Thanks for introducing me. I'm Mayuresh. I'm working as QA architect at Tala. So, of course, the first thing I'm going to do is I'm going to talk about Tala. What do we do? So Tala is in microlending. It offers world's most accessible consumer credit product, instantly underwriting and then dispersing loans to people who don't have easy access to the credit product, loans, or a lot of countries, a lot of emerging nations, they don't have bank accounts, they don't have credit cards, debit cards. So when they go and try to start some small business or they need some money in emergency situations, it's really difficult for them to get any kind of loans. So that's what we do. And all through smartphone app. So Tala just has an Android app for now because a lot of these emerging nations, they don't really have a lot of adoption of iOS. The loans range from $10 to $500, although it seems like a small amount, but if you talk about, let's say, Kenyan shillings, right? If you talk about Kenyan shillings, $10 is like 1,000 shillings there. Who are we serving currently? Kenya, Philippines, Mexico, these are the three countries that we are actively in, and we are trying to expand to other emerging nations as well. And yes, we are hiring, so if you guys are interested, please come see me. All right. So yeah, I'm going to talk about microservices. How many of you guys are dealing with the architecture related to microservices? By show of hands, cool. How many of you guys are on the monolith but planning to move to microservices eventually? All right, cool. So the projects always start with like a few microservices, right? There are a couple of them, then they keep growing, and before you know, you're in the ocean of that, right? Like I think Uber has over 1,000 microservices, I believe. But wait, there's more. It's not just about the RESTful APIs or the services here. We could have a NoSQL, Redis. Could have MySQL, Oracle, SQL Server, or any other kind of data sources. Could have things like Amazon SQS, Kafka, RabbitMQ, any kind of messaging brokers. Could have Cassandra or some other DBs, right? Things get complicated real fast. So then why do orgs switch to microservices? So if things are getting complicated so fast, real quick, there must be some advantages of switching to microservices. Yes, I mean, they're easier to understand, build, deploy, scale. There's less amount of code in one microservices, and it's supposed to do just one thing, right? Like imagine a sign-up flow, right? You create a microservice that just to handle the sign-up flow and nothing else. So it's like any new person joining, making him or her understand how the sign-up flow works and contribute to that code base becomes really easy, right? And building, deploying, and scaling that particular service, it's easy. That results in increase in productivity. Different RESTful services can be developed with different technologies. Let's say one team is working in India or Canada, and another team in US, right? They don't have to stick to the same technologies, right? Like they can play to their skills, and they can develop the different microservices that meet their needs. And businesses don't go down altogether if one or two services die, right? And that could be the problem with a monolith, right? Like imagine an attack happening on the whole monolith application that you guys have. That has the potential to actually bring the whole business down, or at least to a halt, and many more. All right, cool. This by no means is the architecture of Tala. I didn't get permission to show that, so I just came up with something really simple. So on the left, you guys see the Android phone, right? Just think of it as a client, right? It could be iOS app, it could be web app, it could be anything. And on the right side, all these blue things that you see are different microservices. For those who can't see in the back, the names are like pretty simple documents which deal with the images or photos or videos, etc. Those kind of documents stored on Amazon S3. Users, auth, loans, they deal with, of course, user data, authentication, authorization data, loans data, etc. Right? And payments. So think it from the financial product perspective. It could have a third-party payment integration, so that's why there's the rightmost couple of services that I've shown there. So pretty simple architecture so far. So what's the problem, right? The problem is, how do I test all those things? Because I just showed you guys like 5 different microservices, but things can get out of hand real quick, right? It can become 50. How do I ensure all these 50 microservices are doing the things that they're supposed to do? All the API request responses are working the way they're supposed to do. The data quality is great, right? Their performance, like if you run the stress test against them, they're working well, right? How do I ensure all those things? So that's my problem, right? So in this case, when the architecture is keeps getting more and more complex, people usually, by people I mean like the QA team, can usually focus on functional testing on front end, right? Let's say you have the web app, right? It integrates with all the services on the back end. So just by testing that web app, or just by testing the iPhone app or the Android app, you can go through all the flows, right? You can actually verify whether the functionality is working fine or not, which is fine. You can find visible UI issues, you can find usability issues, you can find app crashes or other functional issues, right? And that's great, right? But sometimes finding these issues is a little bit too late. Have any of you guys have heard of a term called as shift left? So what that means is finding the bugs as early as possible in the testing cycle. Left is where your development starts, right? The developer writes code, opens up the pull request, writes unit tests, etc. And then the rightmost part is where you're actually deploying to production and making your product available to the real users. So shift left means in your development lifecycle, if you find those bugs pretty early, that means you're saving a lot of time, resources, and you're able to actually move really fast, because the more bugs you fix on the left side, it's easy for you guys to actually iterate and then push out more and more code. So we did a case study at Tala. We analyzed our current process that was there a year and a half ago. So this is what it looked like. We had bi-weekly releases, and there was a ceremonial process, means like every other Wednesday, 6-7 people would sit down for 5 to 6 hours, and then they would like follow a run book where they would cut the releases of each and every microservice that we had by hand. By hand, I mean they would still trigger a Jenkins job, but it was still pretty much manual process. We call ourselves agile, but that process to me didn't look like agile. It was just something like a faster waterfall, right? Instead of releasing every 3 months, we're releasing every couple weeks. And the testing was there, of course, the solid testing was there. The bugs that I was talking about, yeah, we were catching all those bugs. There was some manual testing, there was a pretty solid automation testing on the front end side using Appium, which worked really great. Each round of automation test would take 6 to 8 hours per country. So I told you guys that we are currently in 3 different countries. So imagine going through the whole regression and taking 6 to 8 hours per country, right? We're running our test in Sauce Labs, but there are multiple platforms using which you can do that, right? Browser Stack, Perfecto Mobile, Amazon Device Farm, you name it. So the total amount that we would need, including the manual test and everything, for all these 3 countries was 3 to 4 days, right? Which was just a little on the higher side. So, and what we observed at the end of these test cycles is we were finding bugs, but 90% of the bugs, or even more than that sometimes, would trace back to one or more backend services. They were not really UI bugs. They were mostly bugs coming due to the wrong responses coming in, or the wrong data in the database that's being set, right? So one or more microservices, or the combination of one or more microservices, was doing something wrong, and that's what we were finding. So it could be data in DB, or app or services performance under heavy load, or it could be purely environmental issues, right? You'll run your Appium test, and they would start failing all of a sudden, right? And you wouldn't know, and then you would suddenly realize someone deployed with wrong config, right? So how do we? So what we are doing wrong? So after analyzing all this, we realized that we are concentrating on like huge amount of efforts on the automation efforts in the areas where we are less likely to discover issues, right? On the UI side, we were barely discovering issues. So of course, we started getting questions like, is the automation even worth it, right? Of course it was worth it, but we were finding the issues really late. So what that means is we were breaking pretty basic testing pyramid that says that you got to be heavy on the bottom where your unit tests are there. Going from bottom to top, you have automated component test, integration test, API test. So what that pyramid says is, as you go from bottom to top, your number of tests can decrease, and that's okay, but you're concentrating on more integrated, more important stuff at that point, right? At the top of that, you'll find automated end-to-end test, and there's a cloud that's saying it's manual exploratory testing, and I'll get back to that, like how and why that's important. And for us, it was time for transformation. So we kind of followed a couple of thumb rules there, right? We had a bunch of microservices, so a lot of REST APIs. So let's define and maintain, of course, clear API contract among services, right? Pro tip, use Swagger. It's pretty easy, it's open source. Avoid sharing data sources. Your different services can own their own data and act upon that data. They don't have to share each other's data, and then services can talk to each other via RESTful APIs, as simple as that. Then we made sure that we have the solid coverage with the unit tests. So what do I mean by solid, right? We defined that 95+% of the mandatory code coverage was necessary. And how do we enforce that? Yes, it's one thing to tell, hey, you know what, like from today onwards, we're gonna have 95% code coverage. It's another thing to actually define that as a step in the Jenkins pipeline so it gets enforced. So we did that. All right. So this is what the simple, the workflow looks like. When the pull request gets created, everyone understands pull request here, right? A GitHub pull request. When the pull request gets created, your application gets built, it gets compiled. We run the unit test, right? It's all part of the Jenkins pipeline. The unit test, if they're passing with a coverage of greater than 95%, we let the build go through. If not, the PR gets blocked, as simple as that. So the next step that we found, of course, the unit tests are good, but they're not going to be good enough, right? Your service is going to be talking to other services. It's going to be integrating with a bunch of data sources. It could be pushing the message to Kafka, or it could be listening for some message. So yeah, so we still needed to test that service in isolation. Why in isolation? Because you don't have to depend on other services while you develop and test your service. Imagine two services that are in development at the same time, but one of them depends on the other, and the other service is not ready yet. So does the testing for first service has to get blocked? Definitely not. You can test for scenarios out of your services control. That's what the testing services in isolation means, and that's what it can give you. The third-party service dependencies are difficult to control and can be expensive. I'm going to give you a practical example. So we were integrating this third-party service that was responsible for sending text messages to our users. And they were charging us, of course, for each text message that we were sending. So we checked with them, hey, do you guys have any non-production sandbox kind of environment which we can use? It's like, no, but you can use our production environment even for your QA testing. It's like, yeah, we can, but we are going to be paying for each test that we run. So, and it did happen accidentally. Like someone misconfigured, and then we were pointing to production. In a 5-minute of load test, we burned like $100. And that load test was barely ramping up at that time. Imagine if we would have actually gone through with that load test, we would have definitely been down by 10 grand in less than an hour. So how do we test those services in isolation? So let's say your services are talking to a couple of other microservices. You're going to mock out all those dependencies, and then you're going to be concentrating just on the service under test. Means rest of the dependencies, you assume that it's a perfect world, and this service, and then you can concentrate on just that service under test. And you're going to take full control of the mocks. I'm not talking about something that, hey, no matter what request you make to this mock, it's just going to return some static hard-coded response. You gotta test a lot of different scenarios. What happens when the service that you depend on returns 200 with the right data? What happens when it doesn't return 200, it returns 404, it returns 500? What happens when that service is down, right? How does your service under test react to that? So you got to take full control of the mocks in order to test your service thoroughly. And of course, do not mock data sources. That's given, relational or NoSQL, because although you're mocking other RESTful APIs, you still got to make sure that you're still testing in slightly similar to production-like scenario. Do not mock message brokers either, because they can sometimes behave really, really weird when you push things out to production. All right, cool. So just to give you guys example of what I mean by that mocking is I've just have this diagram where these are two real services, loans and payments, right? And loans depends on payments, and then loans ask payments that it hits the endpoints and says things like disburse loan, or do the partial repayment, or do the full repayment, right? Imagine the payment service wasn't ready, right? But we have the Swagger, we have the API contract, so we can still test loans service. So what we introduce instead is this payments mock service, right? When we create those mocks, we are still adhering to those API contracts, but we are taking complete control of those mocks, right? We are going to be presetting the response. If the people familiar with the behavioral-driven development and testing, what we do is you have this given when then in the behavioral-driven testing, right? You're basically defining a scenario. In your given, you're presetting the response for the next request that comes your way. And then you're letting loan service hits that payment mock so that you can actually return that set response. So that was about testing services in isolation. But does that mean that the testing is complete? What about the UI test? What about any other kind of testing that might be required? Do we still need that? Do we still need to continue writing hundreds of thousands of the UI automation tests? What about integration tests? What happens when real services talk to each other? No matter how many services you mocked and you proved that your service under test was good enough, you actually throw that in the real world, you are in for surprises sometimes. And is there any other alternative that will alleviate some of the problem? So I'm going to go back to this simple architecture diagram that we saw earlier. Now just imagine So what this Android app is doing is hitting a bunch of microservices in sequence, right? And then it's getting the response from then it's acting upon that. So you definitely can write the automation test that will, you can use the emulator, or you can fire off those tests on some platform like Sauce Labs or Browser Stack. But those tests are pretty slow, right? Like in our case, it was taking 6 to 8 hours. Now imagine that you're getting rid of this Android test and then simply replacing it with simple tools such as Postman, right? In our case, we use Postman, but you could programmatically do that as well. That's not a problem. Postman, because like you're simply hitting the services that your Android client would do, right? Or in your case, if you have web app or iOS app, whatever that client would hit, you're going to hit those services in that exact sequence, and you're going to be running those tests, grabbing the response and validating that response. So why are we doing that, right? Does it mean that we don't need UI automation? No, wrong. That's not the point. We definitely do need the UI automation. We still need some UI tests. So what did we achieve so far, right? In UI tests, in my opinion, what we did was we concentrated on the very basic flow that would cover like the 20% of the test cases that would cover 80% of the basic scenarios that user does go through, right? In our case, the scenarios were actually pretty straightforward. User signs up, user applies for loan, user goes through the disbursement and repayment flow, user responds to the text messages, etc., right? So we could cover all those tests pretty easily, and we didn't need to add a ton of front-end tests that could potentially bring down the runtime pretty well. So instead, we concentrated our time and resources on testing different device types, because Thala is in some markets where we have the brands of the phones that we haven't even heard of here. So we concentrated on different device types, different screen sizes, OS, varying network bandwidth, because that could be a potential issue, app crashes. And the last point is, of course, don't test backend services with UI tests. It's just not a good design on the testing side. And of course, don't eliminate manual exploratory testing. I honestly feel that still has its place in the whole QA lifecycle. Your application is meant to be used by real humans, not by robots, right? So by throwing in a really solid manual tester to actually test out your app or web app or whatever you have, you're actually getting a human perspective from that person, right? And exploratory testing can really find bugs which your automation cannot. So that's where the manual exploratory testing is also important. So after going through all this exercise and we did that transformation, we did find some results, right? And numbers speak for themselves. Initially, like for each country, we had approximately 900 manual tests. After that, we just have 120 odd manual tests now. The time taken was 3 days. It's now half a day. On the front end side, Appium tests, we brought them down from 450 to 90. Sounds like a bad example. People usually try to showcase how they improved their test coverage by adding more and more automated tests. My first 2 rows are exactly the opposite of that. But look at the next 2 rows, right? The integration test. I was talking about the testing services in isolation. Approximately 2,700 of those integration tests that were testing each and every microservice response, the whole JSON body response, the data quality, and everything that we could. And they were running in less than 30 minutes because we could spin them up in parallel and then knock them out pretty easily. End-to-end backend tests, where that Postman logo came in. Approximately 1,300 tests running in less than an hour. That actually means as our manual tests are being executed by QA engineers, rest of the stuff is being executed, and the total time that we are taking for the whole regression for the app plus all the services is half a day. Last thing, what else you shouldn't forget, right? We talked about a bunch of different tests, unit tests, functional tests, integration tests, etc. Load, performance, or stress testing, that's something that you might be in for surprises if we keep forgetting that. Functionally solid products can crumble under heavy load, right? At a minimum, I would say create simple end-to-end simulations where your user can go through and then put it under high load and observe your system, how it performs under that. Make load test part of your CI, right? Like nothing which is developed and run one time is gonna be helpful for you if you don't make it a habit, right, of running that as a part of your CI. Establish clear baseline or SLA, right, and test against that release after release for your every production rollout. Open source tools you can choose from are JMeter, Gatling, and there are a bunch of paid tools as well. Security testing, that's something that we are kind of undergoing that. Of course, being a fintech company, we have to be really secured. And this is the Google Play Store data. 85+% of the mobile apps on the Play Store have security issues and are susceptible to attacks. Native mobile apps have different loopholes than web apps, so let's not make a mistake of assuming that, hey, we tested our web app, right, means everything is good. Native apps can be cracked separately and in pretty weird ways. Incorporate SAST or DAST tools. What that means is static application security testing and dynamic application security testing. They're meant for different purpose. They can be run in tandem. One thing checks for the security loopholes in the code, whereas the other thing actually checks for security loopholes in your application itself, the running application itself. Tools like Checkmarx, Veracode, Now Secure, they can help with that. I think I'm pretty much at the end of it. Yeah. Any questions?
Hey, thank you for the presentation. I think it's perfect element, so like this overview of microservices, and it was really interesting for me. My question is, you said that don't focus on the UI test when you test the backend microservices. So when you do like this UI test with Appium, do you still use thousands of parts of microservices, or you want all the responses from there?
Sorry, your question is, do I still? No.
Responses when you do UI testing.
Yeah, that's a good question. So the people who didn't understand, he's asking, when I do the UI test, are the microservices that the Android app is talking to, are they mocked or they are real services? The answer is actually we did both. Initially, when the microservices were under development, we had all the mocks ready. So we started testing the UI against those mocks, but as the services were ready, we started deploying those in the QA environment, and we started testing the Android app against the real services. Good question.
When we were talking about decision to merge code or not, you said that you accepted 95% of your unit tests passing. What do you do with the up to 5% of unit tests that fail? How do you resolve those code issues as you move forward?
Well, if I have it my way, I'll make that 100%. But yeah, that's something that we decided as a team, because in some scenarios with some technologies, some of the code was not clearly unit testable. And for a better design, we had to let that go, and we had to stick to slightly lower percentage than that. But when I say that 95+% of the unit tests have to pass or have to cover, the code coverage has to be more than that. We still have the next steps, right? The testing services in isolation actually comes next. That can also discover more issues as we go. And when we test those services in isolation, we are actually tracking the code coverage at that point as well. So that helps us there. Does that answer?
Two questions. First one, who is responsible for running unit tests in your team? Is it those developers, or is it on you? And the second one, do you run unit tests and integration tests in CI for every PR? And third question, what is included in integration tests?
For the first question, yes, developers are responsible for writing unit tests. QA usually wouldn't even look at the PR until those unit tests pass. Your second question was, are we running the test with every PR, right? Yeah. So I didn't get a chance to actually showcase the whole CI pipeline that we have built. But yes, so with every PR, the testing services in isolation part, where we were writing those integration tests and executing, that thing happens with every PR and any subsequent commit that's made to that PR, because someone might give the code review comments, right? And then developer might push some more commits to the same PR before merging. So we run those tests for PR and all subsequent commits until the things get merged. Forgot your third question. What is that? What's included? Integration test basically has all the APIs that are being tested, all possible interactions with the other services, and possible responses from those services. So we are testing for all those different variations that can come in. Also, the responses that we have as a part of that integration test, when I mentioned that control your mocks, we are controlling it to the extent that the mock returns the response in exactly the amount of time that we set it to, right? So we could definitely delay that mock response, right? Especially if you're working with the third-party integrations and you're facing the performance issues from their end and you can't do much about it. You actually control the mocks in such a way to mimic the situation that you might face in the real production systems. Okay.
All right, let's give a hand to Mariusz.
Thank you.
Microservices